Bracken Hendricks is the CEO and founder of Urban Ingenuity, and really what we're trying to highlight here again is what's happening in the region and in marketplace development. So we have some excellent examples, one, Montgomery County, and two, a variety of initiatives taking place in DC with the DC government, very supportive of this going on. So Bracken,
great, thanks. I'm Bracken Hendricks. I'm the CEO of Urban Ingenuity. We are a private company based here in Washington, D.C. We run Washington, D.C.'s PACE financing program. It's a long-term form of debt financing for clean energy projects that pay for themselves. So the skill set that we have is taking energy models and merging them with financial models to understand how projects actually get built, how they get built in the market, how they make financial sense, and how we can make clean energy innovation practical. In addition to working to run the DC PACE program, we've actually done a lot of work with affordable housing, with these sort of public institutions that have a long-term time horizon and sort of a public mandate. We've done a lot of work on solar. What we're seeing is that microgrids and this convergence of these sort of individual one-off project-based, things like a solar or a building retrofit is really converging with this district energy infrastructure. And the scale of district energy built around cogeneration with battery storage and solar and electric transmission or distribution is a very, very practical project design and a project type. So I really want to drill down on how these projects get done, but it's more than just the value proposition, it's also the business model. A lot of what's going on in Montgomery County is about how you bring a third party in to make these investments. So I'm going to go quickly through a few slides. We've talked about the value proposition of reliability, of environmental benefits, but bringing it together with the financial benefits is one thing I really want to kind of tease out in this to look at some of the examples. This is just, and Brendan's going to be talking after me, this is the growth of LEED certification. And I actually think that this is a very good precedent for what's happening in energy systems. This sort of slow percolation, it's leading edge, it's long-term, and then suddenly it becomes an expectation in the market. And the technology is not such a stretch, and the business models are more proven, and then you get the sort of exponential leap. And I think we will see that with people demanding greater power quality, greater reliability, and it's actually a way to attract and retain customers in real estate. And I think that the market fundamentals for very secure, reliable, and very green district energy are real. Some discussion was had of it. My kind of pure case is talking about the non-utility, privately owned, multi-user microgrid. Those are a couple loaded words, but it's sort of the hardest case, but it's also a very, very interesting one. How you get multiple users around a common site and how you serve them with a more efficient and more robust infrastructure. And that's what we've been really trying to pull together in Washington, D.C. The economics are really important to understand. These things, if you look at a single benefit, people were talking about gold plating in the earlier round. If you're just trying to get reliability or security, it's an expensive thing to do. But if you start to create a stack of value and you carefully layer, essentially it's line items in a pro forma, where can you crush costs, where can you generate new revenue? When you put all of the constellation of benefits of a microgrid together, the economics are actually very strong. So this is just looking at an actual development in the district that we looked at. And we went through a very detailed construction budget. We looked at, okay, if we pulled out these boilers, these chillers, the cooling tower, we don't have to build a standby generator. All of the capital budget that was eliminated from the project. And then we looked at the ongoing operating pro forma, and we looked at different sort of maintenance and other sorts of benefits. And we came up with real numbers, meaningful numbers for a real estate developer. $5 a square foot, 60 cents a square foot a year. It's not enough that you're gonna just go out and do the project, but that's a positive benefit to your bottom line. It's enough to make the decision to go forward, and that gets to the question of how. It was mentioned that the district government has taken a very proactive stance at a number of different levels. We've just completed a long-term contract with the Department of Energy and Environment, and we were looking at how to support real estate developers on the ground in particular projects. We called it a microgrid extension service, like an agricultural extension service. You want someone to come out, look at your fields, tell you how to do your crop rotation to get a better yield. We feel like folks need that kind of thought about how to think about a physical development. So this is just a map showing almost 100 sites in every ward in the District of Columbia. This is a data-driven scan that we did. We went and we pulled air quality permits. We looked at zoning requests, a bunch of things that were indicators of potential microgrid sites, where there was enough scale, an active project under development. And what we realized is that the opportunity is very, very robust. Some of these have moved, and the microgrid wasn't baked in early enough. So capital cost decisions, civil engineering decisions had been made and foreclosed the opportunity for a microgrid. But many of them are early enough. So then the question is, how do you draw that decision making early enough in the planning process that you don't lock the door on that? And this is some of the work we were doing. The bottom picture is the Walter Reed Army Medical Center in Upper Georgia Avenue, base closing and realignment project, very, very large redevelopment effort, one of the larger sites in the district. And because of a set of requests that the district put in early into the RFP process, there was a request in the designs for people to look at district energy and for them to look at sort of energy and resilience. And so those were built in to the project. We can talk a little more in Q&A if folks are curious. Above is a scan that we did for the General Services Administration through the District of Columbia as our client. But there's the HOTD, the steam plant downtown. They're providing steam on a not terribly profitable basis to provide heating and cooling only for federal customers. So these are simplified, but those light blue we actually merged just so that we don't reveal, security information. But there's basically steam tunnels running through the downtown corridor below the flood zone. The idea of resilience for the core of the federal government is huge. But we looked at if they were just to serve the electricity needs of their government customers and the heating, cooling, and electric needs of those commercial buildings that they actually have steam tunnels running right directly contiguous to. And we discovered it's potentially a $260 million annual opportunity of new markets from the existing infrastructure with modest upgrades. With a $260 million investment, we looked at it a number of different ways, but even a very modest fraction of that is plenty of money to finance a third-party ownership of a new infrastructure investment. This is just very quickly, this is just a graph showing project development life cycles. On the far left, you have very uncertain projects, but they're fairly cheap. And as you try and drive out uncertainty, you have to spend higher and higher amounts of capital investment. One thing we see across the board is that folks come in and they say, I don't know what I don't know, it's too early to spend a lot of money, but help me figure out if there's even an opportunity here. And the industry's kind of centered around, I'm going to give you a robust engineering design for a perfectly specified microgrid. So what we've tried to do at Urban Ingenuity is flip that and do a very, very light touch scan with available data to say, here's how you can go ahead and build this. Another major key point is how to deal with a number of forms of risk in terms of regulatory risk, performance risk, but there are, within contract structures, within business models, within third-party partnerships, there's ways to drive that risk out. I'm just going to show you, really, I think, 2 more slides. The space between the green line and the red line is showing you, for an actual project here in the district, only 4 megawatts of cogen plus another, basically 2 megawatts of solar. That's the difference between the capital cost and the operating expense. So that spread is the margin that you could use to finance third-party investment or to pocket a very meaningful return on this project. And then this is just trying to turn that into an actual financeable project for that customer. And we looked at it unlevered, and then we looked at a levered project. You get greater total returns, but you don't get your payback till about year 8 if it's unlevered. You sacrifice a little bit of your returns, but you pull the payback period much sooner. This is just basically showing that if you have loads that's an asset. Serving those loads is going to be attractive to someone who wants to build a 20-year piece of infrastructure and collect very stable returns in order to serve that. And there's an emerging third-party industry. And then you just build on that, and you can really start to optimize how to add in new benefits, new revenue streams, and get back to that value stacking exercise. And I've gone a little bit over, so appreciate your indulgence. That's who I am, and unfortunately I put some extra slides at the back.